High on a dormant volcano in Hawaii, a telescope stared into the dark before dawn. Somewhere in that ocean of stars, one faint smudge of red sat where no smudge should be. Small. Dim. Almost nothing. To the eye, it looked like a comet, or a stray rock. Reddish. Unsteady in brightness. The kind of dot cameras catch and forget by breakfast. But this one refused to behave. Frame after frame, it slid across the sky along a line that no ordinary comet, no ordinary asteroid ever traces. It moved too fast. It curved the wrong way. It looked like something already leaving. By the time anyone was looking, the thing had already rounded the sun and was racing back out into the dark. Roughly 33 million kilometers from Earth, and shrinking on every image. A visitor caught only on its way out. Where had it come from? What was it made of? And why did it move as if nothing in the entire solar system had made it? On that Hawaiian summit, a single quiet man was about to ask those questions first. That red dot, moving in a way nothing familiar moves, wasn't found by luck. It was pulled out of the sky by a machine built to catch things sliding toward Earth, perched on a mountain in Hawaii called Haleakala. On the 19th of October 2017, a Canadian astronomer named Robert Weryk was sifting through images from the Pan-STARRS 1 telescope. His job was routine. Scan the night's frames, flag anything that had moved between exposures. Most nights brought the usual traffic. Asteroids drifting along their patient loops. Comets on wide, familiar arcs. Everything the survey caught belonged to the sun, bound to it, curving obediently around it. And then one object refused to behave. Its motion looked wrong from the very first frames. Too fast. Too steep. When the software fitted a normal orbit to it, the numbers wouldn't sit still. The curve it drew was too sharp to belong to anything the sun had ever held. So what does an astronomer do when the sky hands him something that shouldn't exist? Robert Weryk didn't announce it. He checked. He pulled more data, worked the trajectory again, and each pass only made the impossible curve sharper. The object was already leaving. Whatever it was, it hadn't slowed for the sun, hadn't been captured by it, and wasn't turning back. It was outbound. And to understand how strange that was, he first had to trace where it had been. That wrongness in the first frame sent Robert Weryk and his colleagues digging backward through the archives, hunting for any earlier glimpse. If something was truly moving that strangely, someone else's telescope might already have caught it. On the 26th of October, the search paid off. Buried in data from the Catalina Sky Survey in Arizona were two faint recovery images of the same object, one taken on the 14th, one on the 17th. It had been there all along. 2 extra dates may sound like nothing, but for astronomers plotting a path across the sky, every earlier point is gold. Each old image stretched the line the object had traveled, and a longer line tells a sharper truth. By stitching the Catalina sightings onto the newer frames, the team assembled a 2-week observation arc. 14 days of motion, from mid-October outward. And when they fit a curve to those points, the shape of the path began to reveal itself. It was not the gentle closed loop of a body bound to the sun. The curve bent open, hurtling. The early fit hinted at a strongly hyperbolic orbit, a trajectory that arrives from nowhere and returns to nowhere. Could that really be right? A 2-week arc is short. Astronomers knew it and stayed cautious. Yet even those 14 days refused to fold the object into any orbit around our sun. Something had come in fast, from far away, and it was not staying. That hyperbolic curve did more than mark where the object was going. Run it backward through the calendar, and it told a stranger truth about when it had been closest to us, and how badly we had missed it. Because the closest it ever came to the sun happened on the 9th of September, weeks before anyone knew it existed. It swung in, whipped around our star, and started climbing back out into the dark, unseen and unrecorded. Roughly 40 days later, on the 19th of October, the telescope on Haleakala finally caught it. 40 days. By then, the visitor had already turned its back on the sun and was leaving. When Pan-STARRS first pinned it down, the object sat about 33 million kilometers from Earth. 21 million miles. Around 85 times farther than the Moon, and every hour that gap was widening. Think of what that meant. Every earlier close-up view, every chance to watch it sunlit and steaming, had already come and gone before a single instrument turned its way. The show was over. Astronomers had walked in on the encore. So the questions everyone wanted answered would have to be pulled from a fleeing dot on its way out the door. What was it made of? Where had it come from? And why was it moving the way it was? The clock had already started. Catching the visitor on its way out gave astronomers only weeks of measurements, and every fresh frame sharpened one number that refused to behave. It was the shape of the orbit itself, and that shape was wrong. Every comet, every asteroid, every planet that belongs to our sun rides a closed loop. It curves out, it swings back, it comes home. The sun holds them. Its gravity draws a leash no ordinary rock can break. Astronomers measure how stretched an orbit is with a single value called eccentricity. A perfect circle is 0. A long, thin loop climbs toward 1. But at 1.0, something snaps. The leash breaks. The path stops closing. As the 2-week arc grew into observations spanning 80 days, the answer settled at 1.20. Eccentricity of 1.2, the highest ever recorded up to that moment. This was no loop at all. It was an open road. Then came the speed. Strip away the sun's pull, run the object far out into empty space, and it still carried a leftover velocity of 26.33 kilometers per second. Roughly 95,000 kilometers an hour it would never lose. That surplus speed meant it had cleared the sun's escape velocity with room to spare. Nothing born in our system arrives already moving that fast. It hadn't been flung loose from some far planet. It had come in from outside, carrying its own momentum. By the middle of November, the doubt was gone. The trajectory was unmistakably hyperbolic, the speed impossible for a local body. Astronomers were now certain of something no one had ever confirmed before. This thing had been born under another star. So a number had told astronomers where this thing was going. But it still had no proper name, and the people who cataloged the sky suddenly faced a problem they had never faced before. The International Astronomical Union assigns designations for every comet, asteroid, and moon we find. Their whole system assumes an object belongs to our sun. This one did not. How do you file a visitor that was never ours? At first they treated it as a comet, cataloging it as C/2017 U1. Then, when no misty halo appeared around it, they reclassified it as an asteroid, A/2017 U1. Even the label kept changing beneath their hands. But neither label was honest. This object came from beyond the sun's grip entirely, and no existing category admitted such a thing. So the Union did something rare. They invented a brand new class. The letter chosen was I, for interstellar. As the very first object ever identified this way, it took the number 1. 1I. The catalog would forever remember it as the first of its kind. A number is not a name, though. Discovered from Hawaii, it deserved a Hawaiian one. The Pan-STARRS team turned to 2 language experts, Kayu Kimura and Larry Kimura at the University of Hawaii at Hilo. They chose Oumuamua, roughly a scout, a first distant messenger reaching out from the deep past. It begins not with an apostrophe, but an okina. a soft glottal catch in the throat. A messenger, finally, with a name. The name gave it dignity, but a scout does not linger, and this one was already running. From the moment it had a designation, astronomers around the world knew they were racing a fading spark that would never come back. At Haleakala, pan-stars had found it. Now the Canada, France, Hawaii telescope turned toward the same patch of sky, refining a path that already looked impossible, its wide field sweeping the outbound Speck night after night. In Chile, the giants joined the chase. The Very Large Telescope, Gemini South, high in the Andes. Their mirrors gathered every stray photon from an object that was already millions of kilometers further away with each passing hour. In Hawaii, the Keck telescope pressed its enormous segmented eye to the same faint target. But the problem was cruel. The object was small, dim, and moving fast enough that it smeared across the frame as the shutters opened. How faint was it, really? By the end of October, it had already dimmed to about apparent magnitude 23, near the edge of what the largest ground telescopes on Earth could pull out of the dark. So they reached above the atmosphere. After the announcement, the space-based observatories joined in. Hubble, from orbit, and the infrared eye of Spitzer both turned toward a visitor already slipping past the reach of anything below the clouds. It was a campaign against a clock no one could stop. Every instrument that mattered aimed at one fleeing dot, gathering what fragments of light they could before the visitor vanished into the black for good. But even as it slipped past the reach of the biggest mirrors on Earth, the data it had already surrendered held a puzzle. Not in how bright it was, but in how that brightness kept changing. Astronomers watched the object's light rise and fall as it turned in space. This is called a light curve. And this one swung wildly, from dim to bright and back, over just hours. The size of that swing told the researchers something startling. To brighten and darken that much as it spun, the object had to be extraordinarily long compared to how wide it was. Estimates put its length somewhere between 100 and 1,000 meters. Yet its width and thickness were thought to be far smaller, perhaps only tens of meters across. A shape almost no natural body in the solar system shares. And there was its color, a deep, dusty red, the same hue seen on distant objects at the frozen edge of our own solar system, worn by ages of radiation. It looked old. It looked like a traveler. Stranger still was how it moved. The light curve, assuming little error, suggested it was not spinning cleanly on one axis. It was tumbling, end over end, chaotically, as if something had knocked it off balance long ago. A long, thin, reddish shard spun into a slow tumble, racing through our solar system from somewhere unknown. It was that shape, more than anything, that pushed some to ask a question they could not quite shake. Could it really be natural? That strange, tumbling shape had astronomers reaching for the closest thing they knew. An elongated body, reddish, wheeling end over end through the dark. The obvious guess was a comet, a wanderer of ice and dust. So they watched for the one thing a comet always shows. A comet near the sun is unmistakable. Sunlight boils its frozen surface, and gas and dust stream off into a glowing haze, a soft nebula wrapped around the nucleus. That haze has a name. Astronomers call it a coma, and this object had come close to the sun. Only weeks earlier, it had swung through its closest point to the sun. Solar heat should have been peeling it open, dragging a bright veil behind it. Every telescope that turned to it looked for that telltale glow, and found nothing. No haze, no tail, no coma at all. How could that be? An icy body that had just grazed the sun's furnace, and yet it stayed cold, bare, silent. No sublimating gas, no dust plume catching the light. Just a dark, hard shape, giving away nothing about what it was made of. The classification had to change. It had first been logged as Comet C/2017 U1, a natural assumption for something arriving from the deep. But with no coma to justify the label, the record was rewritten. It became A/2017 U1, an asteroid. But that reclassification only sharpened the puzzle. A comet with no coma is odd. An asteroid, though, is supposed to just fall, obedient to gravity, following the sun's pull and nothing else. This one wasn't going to be so obedient. Something was still pushing it. So the label had shifted from comet to asteroid, a bare rock with no breath around it. But a rock is supposed to obey one thing above all else. It is supposed to fall exactly as gravity commands. As astronomers plotted its outbound track, they mapped where the sun's pull should carry it, month after month. Then they compared that map to where the object actually was. The two lines did not match. The visitor was moving too fast. Something, faint but unmistakable, was giving it an extra push away from the sun. A tiny nudge that gravity alone could never explain, according to the observations of the team tracking it. For a comet, this would be routine. Ice boils off near the sun, jets fire like tiny engines, and the body accelerates. But that push always leaves a signature you can see. A glowing coma. A tail. This object had none of it. No halo, no tail, no cloud of dust catching the light. Just a bare, silent point of reddish rock being shoved along by a force that showed itself in the numbers and nowhere else. How do you push something across space without a whisper of exhaust? Some suggested pressure from sunlight itself, others invisible outgassing. But with no coma to point to, the answer stayed hidden. And that single anomaly would fuel every wild theory that followed. A push with no tail. That was the puzzle that sent minds racing past the language of physics and into the language of fiction, because there was one story that fit the shape of this thing almost too well. In 1973, the author Arthur C. Clarke published a novel called Rendezvous with Rama. In it, a vast alien vessel drifts silently into the solar system, unannounced, cylindrical, elongated, sweeping past the sun and out again. The parallels were uncomfortable. A visitor from beyond, unusually elongated, arriving without warning and leaving just as fast. Some on the Pan-STARRS team even floated Rama as a name for their strange red speck before the final choice was made. Fiction is one thing. But if this really was something more than rock and ice, there was a way to test it. You listen. You point the world's radio dishes at it and wait for something to speak. So the SETI Institute turned its Allen telescope array on the outbound visitor, sweeping across its position, straining for any hum, any hiss, any narrow tone that nature does not make. The dishes listened. Nothing came back. Then came the heavier instruments. The Breakthrough Listen project trained the enormous Green Bank telescope on the object, its data combed for narrowband signals, the artificial kind. Again, silence. No transmitter, no signature, no voice. And the search was extraordinarily sensitive. Given how close the visitor passed, the listening ruled out any transmitter broadcasting with even a fraction of a watt, down to about 0.08 of a watt. Whatever it was not calling home. So if no signal ever came, the next question was almost inevitable. Not what was it saying, but where had it come from? And the answer, when astronomers traced its path backward through the dark, pointed at a single bright star. Vega. A blazing beacon in the constellation Lyra, one of the brightest stars in the northern sky. When they extended the visitor's incoming trajectory, it seemed to arrive from roughly that direction, out of the harp-shaped pattern of stars overhead. But Vega itself was almost certainly not the true home. Stars drift. In the long ages this object had been traveling, Vega had moved far from where it once sat. The direction was a clue, not an address. What made the geometry compelling was another number. Its inbound path came from just 6 degrees off the solar apex, the exact direction our own sun is plowing through the local stars. A near-perfect line into the oncoming traffic. Why does that matter? Because a true interstellar wanderer, drifting nearly still while the sun rushes forward, would most likely appear to strike us head-on, from ahead. That is precisely where this object seemed to come from. And yet, for all the arrows pointing toward Lyra, the honest answer stayed the same. Its planetary system of origin was unknown. Its age, unknown. It had come from somewhere out there, and somewhere was all anyone could say. That system, wherever it was, had sent something so strange that astronomers could not agree on what it was. And when a strange object arrives with no return address, the first task is to find the ordinary explanation that fits. But every ordinary explanation had a flaw. One idea was the simplest: a rubble pile. A loose heap of rock and dust held together by little more than its own weak gravity, drifting for ages between the stars. Familiar. Reassuring. But there was a catch buried in the numbers. For a loose rubble pile to survive its tumbling shape, Oumuamua would need a density like an ordinary rocky asteroid. Solid stone. Yet, a rival picture suggested something else entirely. Something far lighter. If Oumuamua held even a little internal strength, the kind icy comets carry, it could be far less dense than any boulder. A fragile, low-density body, held together not by weight, but by ice. Two very different objects, both fitting the same faint smudge of data. So where would such a thing come from? Some researchers proposed it was the remnant of a rogue comet, a wanderer with no star, slowly torn apart over unimaginable time until only this splinter remained, still coasting through the dark. Then came a stranger notion still. What if Oumuamua was a chip knocked off a distant world? A shard of an exoplanet rich in nitrogen ice, a place not unlike Pluto, blasted free and flung across the galaxy. A splinter of another world's frozen skin, carrying the memory of a place no one had ever seen. Each theory was plausible. Each left a thread untied. And that one stubborn thread, the push with no visible cause, refused to be explained away. None of those theories quite closed the case, and the deepest crack ran through the one detail no rock could explain. That gentle outward push, riding along with no comet's veil to account for it. In March of 2023, a new answer arrived. The proposal was almost quiet in its logic. What if the object had never needed a jet of dust at all? What if the thing pushing it was invisible, escaping from deep inside a body of ancient, frozen water? The idea centered on molecular hydrogen, trapped inside a water-rich icy body, formed over eons as cosmic radiation slowly worked on that ice, splitting and rearranging it. A store of gas locked in the frozen dark, waiting. As the object neared warmth, that entombed hydrogen began to slip free. A slow, steady release spread across its surface, invisible to any telescope. No coma to see. Just a soft, continuous shove, nudging it faster on its way out. If that held, the strangeness dissolved. No spacecraft. No engine. Just physics playing out on a fragment of frozen water that had wandered farther than anything humans had ever measured. According to the researchers, it was, at heart, an interstellar comet. A planetesimal relic, they suggested, broadly like the comets born in our own solar system. Not a messenger with a purpose, but a leftover from some other world's beginning, still carrying the chemistry of its birth. Yet even a tidy answer could not silence every question. For all the elegance of a hydrogen answer, no single verdict ever quite closed the case. By July of 2019, most astronomers had settled on the plainest conclusion available to them. Whatever the visitor was, it was almost certainly a natural object. Natural, but not simple. That word papered over a stubborn truth. The object had slipped through the solar system in weeks, seen only on its way out, and the window to study it had been cruelly short. So the precise character of the thing stayed contentious. Was it a rubble pile? An icy shard? A fragment of some distant world? Every model fit some of the data and stumbled on the rest, and no one could go back and look again. And then, barely a month after that cautious verdict, in August of 2019, an amateur astronomer named Gennady Borisov swept his homemade telescope across the pre-dawn sky in Crimea and caught something moving wrong all over again. This one wore a coma and a tail, a proper comet from another star, later named 2I/Borisov. The visitor from Lyra had not been a fluke. It had a sister. And that changed the whole question, because suddenly the sky was no longer empty of strangers. So it was not alone. But the first scout was already slipping past the reach of every instrument that had ever touched it, fainter with each passing night, falling away toward the dark it had come from. By mid-December of 2017, it was gone from us for good. Too faint, too fast. Even the largest telescopes on the ground could no longer separate its dim smear of light from the noise of the night sky. And here is what haunts the astronomers who chased it. On the path it was measured to travel, it cannot be captured. No orbit will ever bend it back. It is climbing away from our sun, and it will not return. Every answer we might have pulled from it, it carried away with it. The shape we could only infer from flickering light. The push with no tail. The world it was born in, all of it, still locked inside a red speck now beyond our reach. But it left us something larger than any single answer. Before that October in Hawaii, no one had ever confirmed a visitor from another star crossing our own. Now we know they come, quietly, unannounced. And we caught this one only as it was leaving. So how many have already slipped through, unseen, in the ages before we knew to look? Its name means the scout, the first messenger reaching out from the distant past. And it has gone home, carrying its secrets into the dark. If you have a theory about what Oumuamua truly was, tell me in the comments and tell me which unsolved case you want next. Subscribe and stay with the unsolved.